Time travel for your code. That's the honest, one-sentence pitch for the tool you're about to understand. Git lets you save your project at any moment, jump back to exactly how it looked last Tuesday, try a wild idea on the side, and work with other people without ever overriding each other's changes. If you've ever zipped a folder called final, then final2, then final really this time, you already felt the problem Git solves. By the end of this, commits, branches, and pushing to GitHub will stop being scary words and start becoming muscle memory. So let's build the whole mental model from zero, one piece at a time. Picture how people used to save their work before version control existed. You finish something, so you copy the entire folder and rename it with today's date. Tomorrow you copy it again. A week later your desktop is a graveyard of folders, project, project new, project final fixed, and you honestly have no idea which one still works. Now add a teammate. They email you their copy, you email yours, and somewhere in the middle two changes collide, and one of you quietly loses an afternoon of work. There's no history you can trust, no way to see who changed what, and no safe place to experiment. And because deleting anything feels dangerous, you never clean up, you just keep piling on more copies. That whole mess is exactly the hole Git was built to fill. So here is the core idea, and it's smaller than you'd think. Git is a version control system. That's just a fancy way of saying it records the history of your project as a series of saved states, and it lets you move through that history freely. Instead of copying the whole folder, you tell Git, remember the project exactly as it is right now. Git files that snapshot away with a label, and your working folder stays a single, clean place to work. Do that again later, and you've got 2 points in history. Do it 100 times, and you've got a complete, walkable timeline of everything that ever happened to your code. Let me introduce the tool itself. This is Git, a small, free, open-source program that runs right on your own machine. It was written back in 2005 by Linus Torvalds, the same person who created Linux, because he needed a fast way to manage a giant project with thousands of contributors. The key word is distributed. Every single person working on a project gets a full copy of the entire history on their own computer. Not just the latest version, the whole thing. That means you can work offline, save as often as you like, and never depend on one central server just to record your progress. Today, roughly 9 out of 10 developers on the planet use it, which means learning Git isn't optional, it's the shared language of how software gets built. Git lives in your terminal, but every button in every fancy Git app is really just calling these same commands underneath. The single most important word in all of Git is commit. A commit is a snapshot, a saved photograph of your entire project at one exact moment in time. Making one is a simple 2-step move. First, you stage the exact changes you want to include, which is like putting them in a box. Then you commit that box, and Git freezes those files and attaches a short message from you, like fixed the login bug or added the checkout page. That message is a note to your future self and to your teammates. A commit is small and cheap, so you'll make several a day, one for the button you fixed, one for the typo you caught, one for the feature you finished. String your commits together and you're not just saving files, you're writing the story of how your project came to be, one labeled snapshot at a time. Now here is a detail that makes the whole thing trustworthy. Every commit gets its own name automatically, a unique fingerprint, 40 characters long, made of letters and numbers. It looks like random gibberish, and it's generated directly from the exact contents of that snapshot. Here's why that's clever. If even a single character in a single file changes, the fingerprint comes out completely different. So that 40-character code is a tamper-proof ID for one precise version of your project. You never have to memorize it. Most of the time you'll only see the first 7 characters, but it's the reason Git can promise that the snapshot you saved is byte for byte the snapshot you get back. String those snapshots together and you get the picture at the heart of Git, the commit graph. Imagine a row of dots on a line. Each dot is a commit, a snapshot, and each one points back to the one before it like beads on a string. The newest commit sits on the end. The very first one anchors the other. This chain is your timeline, and it's what makes the time travel real. Want to see the project as it was 50 commits ago? Git rebuilds that exact state instantly. Made a change today that broke everything. You can walk back to any earlier dot, look around, and reset to it. Nothing is ever truly lost, because every point on that line is still sitting there safe. This single idea, a chain of snapshots you can revisit at any time, is the thing that turns "I hope I don't break it" into "go ahead and break it, I can always come back." But a straight line is not enough for real work, and this is where Git gets genuinely powerful. You can branch. A branch is a parallel timeline that splits off from the main one. Say your project is humming along on the main branch, and you want to try a risky new feature. Instead of editing the live code and hoping, you create a branch, call it new checkout, and your timeline forks in two. On that branch you save freely, experiment, break things, fix them. The whole time the main branch sits untouched, exactly as it was. Branches are cheap and instant, so making one costs you nothing. This is also how a team avoids stepping on each other. Everyone works on their own branch at the same time, so two people can build two different features in parallel without their changes ever colliding until they're ready. That's the mental unlock. You never have to choose between trying something bold and keeping a version that works. You get both side by side. Two timelines are only useful if you can bring them back together, and that move is called a merge. When your feature on the side branch is finally working, you merge it into main and Git weaves the two histories into one. Most of the time this is automatic. Git is remarkably good at figuring out how to combine changes. But sometimes two branches edited the very same line of the very same file in different ways, and Git honestly cannot know which one you meant. That's a merge conflict, and I want to say this clearly. Conflicts are completely normal. They are not errors, and they are not a sign you did something wrong. Git just pauses, shows you both versions side by side, and asks you to choose. You pick the right result, you finish the merge, and the timelines become one again. When the merge completes, Git records a fresh commit that has two parents, the two branches you just joined, so the history remembers that they were ever separate. That's the full loop, split off to work in safety, then merge to bring it home. Everything so far lives on your own machine. So how do teams actually share all of this? With a remote, a copy of the repository that lives on a server everyone can reach. And the most popular place to keep that shared copy is GitHub. Picture two sides. On the left, your local repo, the full history sitting on your laptop. On the right, the remote on GitHub, the shared source of truth. The two stay in sync by sending commits back and forth. When you're ready to share your work, you push your commits up to GitHub. When you want a teammate's latest work, you pull their commits down. And because a clone is a full copy, a brand new teammate can join, clone the repo once, and instantly hold the entire history of the project on their laptop. Every commit, every branch from day one. GitHub itself doesn't replace Git, it's Git's history hosted online, wrapped in a friendly website so a whole team can gather around one copy. In practice, this becomes a rhythm you'll repeat every single day, and it's only a handful of steps. If you're starting from a project that already lives on GitHub, you clone it once. That pulls the entire history down to your machine. Then the loop begins. You edit some files. You add the changes you want to keep, staging them into that box. You commit the box with a clear message, and when you're ready, you push it up so everyone else can see it. Edit, add, commit, push. Before you start a fresh chunk of work, you pull first to grab whatever your teammates shipped while you were away. That's the entire everyday workflow. Clone once, then edit, add, commit, push on repeat with a pull to stay current. Master those few words and you can work on almost any codebase on Earth. This is all completely real, and you can go look at it right now. Every public project on GitHub shows its full commit history, the exact chain of snapshots we've been drawing made by real people. Here's the commits page of a well-known open source project. Every row is one commit. The message someone wrote, who made it, when, and that short fingerprint off to the side. Scroll and you are literally reading the timeline of how that software was built, snapshot by snapshot. This is the payoff of the entire model. It isn't some abstraction living in your terminal. It's a durable, public, walkable record, and it's the same machinery whether you're one person on a weekend project or thousands of engineers on something enormous. So why should you actually care, beyond simply not losing files? 3 big reasons. First, undo becomes fearless. Any change you make is safe because you can always walk back to a working snapshot, so you experiment more, not less. Second, real collaboration. A whole team can work on the same project at the same time, each on their own branch, and merge their work cleanly instead of overriding each other. That single capability is what makes modern software teams possible at all. And third, history you can actually question. Because every commit records who changed what, when, and why. You can point at any line of code and ask, when did this appear and what was the reason? A year from now, when something breaks, that record is what lets you find the exact commit that introduced the problem instead of guessing. Git turns your project from a fragile pile of files into an accountable, living record. A few honest habits will save you real pain, so let me hand them to you right now. 1. Commit small and commit often. A commit for each meaningful little change is far easier to understand and undo than one giant commit at the end of the week. 2. Write real messages. Fix the bug helps nobody in 3 months. Say which bug and why. 3. Use a file called .gitignore to tell Git which files to skip, like temporary junk and huge build folders. 4, and this is the big one, never commit secrets. Passwords, keys, private tokens, once they are in the history, they are painfully hard to fully erase, so keep them out from the very start. And remember, merge conflicts are normal. Everyone hits them from your first week to your 10th year. They're just a question Git is asking you, not a catastrophe. Do these 5 things and you'll skip the mistakes that trip up almost every beginner. So let us tie the whole thing together in 3 lines. 1. Git is a version control system that saves snapshots of your project called commits so you can move through its history at will. 2. Branches let you split off parallel timelines to work safely, and merging brings them back together. And 3. A remote like GitHub holds the shared copy and you stay in sync by pushing your work up and pulling everyone else's down. Commits are the memory, branches are the freedom, and the remote is the meeting place. That is the entire heart of Git. And honestly, it's most of what you'll ever use. If Git finally clicked for you today, then you are ready for the tool built right on top of it. Next in the series, we go deeper into GitHub and pull requests, how teams actually review each other's changes, discuss them, and merge them into the main project with real confidence. It's where Git stops being a solo skill and becomes how the whole world builds software together. Subscribe so you don't miss it, and then go make your very first commit, because the best way to learn all of this is to start your own timeline today.